In this section, we'll perform a network-based installation of Red Hat Enterprise. Let's log in to our host system, the VMware host system, as the user root. And once in, we will launch the VMware console, plus open a shell to show you how we've set up the environment. So we've got the Red Hat Enterprise server boot ISO image on this particular CD-ROM. This is not the first CD-ROM or the full DVD, just the boot ISO image. You can obtain the boot ISO image from the first CD-ROM or from the DVD-ROM from the images subdirectory. There's a file named boot.iso. If you burn that file, you'll be able to boot your system into a network-based installation. So we've got that in our system. In addition, we've set up the network. Let's open a shell to show you where we've published the full DVD image using the ISO image. We'll SSH over to the Media 1 box, 192.168.75.100. And there's a web root beneath serve www.linuxcbt.com. And beneath there, we've created a directory, an uppercase labeled directory RH5. Beneath RH5, we've created i386, and we've mounted the DVD-ROM to this directory. In fact, the du-ch of this directory tree reveals that it's 2.8 gigabytes, roughly the size of the full DVD-ROM. So this is the full tree, and when we reference the tree from the installation program, we'll be referencing the root of the website using the IP address of the server, followed by RH5 uppercase, and then i386. Now, as far as the ISO image, if we type mount, we'll see that currently the ISO image is being referenced from this full path, LinuxCBT EL5 edition, and the name of the image is RHEL-5.1 for i386. Let's LSLTRH this file to see its size, and there you see it's 2.8 gigabytes. So this is the main DVD image that we downloaded from redhat.com. Again, it requires a trial or a subscription to gain access to the ISO image. And we've mounted it using mount type ISO 9660, option loop, followed by the source file, which is the ISO file, followed by the destination directory. And we'll update our notes once we've relogged into our remote system. In fact, the remote system's up, so we can connect to it now and do so. Let's copy the mount command. And in a separate shell, we'll SSH to 192.168.75.10. That's the other Red Hat Enterprise box on the wire. We'll then SU in as LinuxCBT, the user in which we've been operating, and in that directory we'll find the EL5 notes file. So let's modify it. And there's the file. So, in a separate section, we'll create a header for install RH5 using the network. In our case, we'll use HTTP. And the general steps include download ISO image, preferably the DVD ISO image for RH5. However, you can mount the individual CD images or concatenate or create multiple disks beneath your top-level directory, such as disk 1 through disk 5, and copy the contents of each disk into each of the directories. But it's easier if you use the DVD ISO image. So download the DVD ISO image, create a directory beneath your web root, for example, serve www.rh5 i386 as an example. Our directory is slightly different. In fact, it's linuxcbt.com rh5 i386. We indicate i386 to represent the platform in the event that you'd like your web server to host multiple platforms of the binary code for the operating system. So for example, you could have RH5 AMD64, i386, Intel, or IA64. Next, mount the DVD ISO image to the web root as follows. Source ISO image and destination. In this case, the destination is serve www linuxcdt.com rh5 i386. Test that it's accessible, so test accessibility using a web browser. And this could be a text-based web browser if you like, such as links. However, it's simple to launch Firefox and try it graphically. So we'll test it very quickly. We'll start a new session and attempt to access that path. So that's 192.168.75.100 rh5 i386. And there you see the full directory tree. You should also ensure that your Apache web server or iOS web server permits directory indexes. So let's just note ensure that web server permits directory browsing or indexes, auto indexes in Apache, so that you're able to see a formatted presentation of the directory, since there will be no default start file such as index.html. So here are the different directories and files that are included. There's software for cluster storage and clustering. If you navigate, you'll see many RPMs that includes the cluster administration and cluster software, end user license agreement, GPL, readmes in different languages, release notes in different languages, the server top-level directory, which contains all of the RPMs that constitutes the build. We've got our virtual technology or virtualization subdirectory, which contains the virtualization code for different languages. An images subdirectory, this is where you'll find the boot.iso image. Use this boot.iso image, and we should just make note of that, to create your boot CD that we currently have plugged into our machine. So step 5, create boot CD-ROM using images boot.iso, or optionally boot with a first CD-ROM of 5, or B DVD-ROM. So you can boot with either of these to install the system, but creating the boot ISO CD is very quick. As you can see, it's 7.2 megabytes. There are other images in this directory, including diskboot.image, which you can use for USB pen devices, PixieBoot for booting using PXE, and other files. But the key files are boot.iso and diskboot.image. When you boot your system using the network-based boot, it searches for the mini stage 2 and the stage 2 boot files. So these are required. And ISO Linux is a non-ISO version of the boot files. In the event that you needed to create, for example, a custom boot CD-ROM, perhaps with your own Kickstart configuration file, this directory represents what you'd find in your boot.iso image. In fact, if you total it up, it's roughly the 7.2 megs listed for the boot.iso image. So ISO Linux basically is a boot environment. You can burn it as is and boot from a CD-ROM. When you burn boot.iso, it expands to what you see here in ISO Linux, in the ISO Linux subdirectory. So this is the directory tree. It is accessible. That's good news. That means from VMware or from our dedicated physical server, when we try the network-based installation, we'll be able to access the files. So now that looks good, the fifth step is to boot the server with the bootable media and indicate Linux ask method to force the Red Hat Anaconda installer to prompt us for the method of installation, whether FTP, CD-ROM, local hard drive, HTTP, and so on. And that's the stage we're at now. So with that said, let's save the changes to our documentation using Control-O. We'll then launch the VMware Server Console in the background. This will bring up a session of VMware, and we will look at our VMware sets. We have an existing set. We could overwrite the existing inventory. Let's navigate to that existing item, and we've got RH5 instance 1. When we power this on, it'll boot with the CD-ROM. But you need to be sure that the virtual machine will boot with the CD-ROM as the default boot device. So let's go ahead and attempt to power on the virtual machine. And this will fire up very quickly. And we'll know whether or not it boots from the CD-ROM. As you can see, it has not. So the ideal thing to do here is reset this machine, because it's booting directly from the hard drive as opposed to from the CD-ROM. So we'll reboot and then navigate to the boot option. As you can see, removable devices comes before hard drive and then CD-ROM. So we need to move CD-ROM towards the top of the list. We'll use plus to push it up to the top, and then we'll exit, saving the changes, and this will boot from the CD-ROM. Momentarily, we'll be presented with the boot menu, and this is the installation menu. So here is where we would type Linux ask method. Additionally, if you'd like to install using the text-based installer, append text is an option. So you begin your options by indicating Linux, followed by any number of options such as ask method, text, so on and so forth. Let's move forward. This loads the kernel. It begins detection. It loads the various drivers for the different storage subsystems, and we should be propelled into the installer mode. Momentarily we will be prompted for the installation source, which again can be one of many, including HTTP, FTP, NFS, local media such as CD-ROM or DVD drive, or even a local hard drive. Various drivers are being loaded. We need to indicate the language for both the keyboard as well as the installation. And here are the different sources, the possible sources. So as mentioned, HTTP is our desired method of installation. Since we already have an Apache web server up and running, we could have set up a VSFTPD or ProFTPD instance. However, our Apache server is there, so we'll use it. We need to determine what to do with IPv4 and IPv6. Both are set to automatic, which means this installer or this instance will obtain its IP address dynamically using DHCP. Sending a request to the DHCP server, and if all goes well, we'll make it to the next step. And now we need to indicate the IP address, or optionally the host name of the source server, or the server housing the binary code to install Red Hat Enterprise. So we'll indicate the IP address just in the event that name resolution is not available, although it usually is if your DHCP server has handed it out. So the server's IP address is .100, and the directory relative to the server is /RH5. Now this isn't the absolute directory, this is the web accessible directory. So it's RH5 I386. You can pull this directly from what we indicated in the text file or specify below in the web browser, index of /RH5 I386. From there, the installation process will find the remainder of the files. And the next window will tell us whether or not it's found it, and there you see it's retrieving images, ministage2.image. That means it's pulling, or it has pulled the file from the server and will pull subsequent files from the server. So this is looking good thus far. It has detected a VMware graphics adapter, but a graphical installation will not be performed. And now we're ready to perform a text-based installation of Red Hat Enterprise, across the wire, of course. So let's skip entering an installation number. You only enter the installation number for your production systems, as they're tied to whatever subscription you've agreed to. So keep that in mind. It tells you above it, again, if you're unable to locate it, you may miss out on certain things, but that's fine. Because again, our intent and purpose is to show you how to install using HTTP or across the wire. Now it has located an instance, and we can determine what to do. So we either choose one to upgrade or reinstall altogether. Reinstall is equivalent to installing the system fresh. So we'll enter OK, and this propels us to the next step where we can determine what to do with the partitions. We can also create a custom layout for our partitions. So here we have the opportunity to effect a customized partition, which is one of the requirements for certification within the Red Hat world. So rather than accepting the default proposal of a large root or a large / and a swap file, we can create a custom layout. Now, had we had more drives, or more virtual drives in this case, we'd be able to create a RAID setup, like a RAID 5 or RAID 1 or 0, but we'll look at that in a subsequent section. For now, we're working with one hard drive, SDA, which means it's a SCSI or a SCSI emulated hard drive, or even SATA-based hard drive, which tends to take the S prefix as opposed to the H prefix. H is for TAPI IDE hard drives. So SDA is our lone 8 GB hard drive, which we can customize. Generally, it's suggested that you break your key partitions, such as var, home, and root and boot, into distinct partition chunks in the event that one becomes overwhelmed with data or flooded with information. It doesn't usurp or compromise the other partitions. However, in the case of one large / or one large root partition, if in the event that one of the directories or mount points such as var within that one large partition becomes overwhelmed, you run the risk of exhausting all of the space on the user space hard drive or user space mount point, which could result in a denial of service or the inability for you to use the system. So it is ideal for you to separate your partitions out. So let's select to move forward with Create Custom Layout by tabbing down to OK and pressing Enter on OK. Now, here's the existing layout. A logical volume group exists named vol group 00. A logical volume vol 0 exists, and it's ext3, and it represents the root file system. Another logical volume 01 exists for the swap partition. The boot partition, however, ext3 is SDA1, and it stands alone at roughly 100 megabytes. So this is the current layout. We need to delete the current layout and create a new layout. It doesn't have to be LVM based. We'll also be looking at LVM during installation as well as once the system's up and running later on. For now, we're just going to create basic partitions to illustrate the point. So let's delete the different partitions. In this case, we need to select an individual partition such as SDA1. And each partition, as you can see, begins with 1 and increments by 1. So SDA1 is the first partition on the first hard drive, equivalent to HD 0, in grub terminology. So let's delete it, and we'll get rid of SDA2, and we'll have free space to partition. So now we've got the full 8 gigabytes free, or 8192 megabytes to partition. So to partition, you navigate to New using the arrow key left or right to get to New, or you can press F2. The function keys are below, and then you determine the mount point. So we'll start by creating a boot partition. A boot partition is where the kernel is housed, meaning the Linux kernel, as well as the other key boot files, such as the grub bootloader for stage 1, 1.5, and 2. So when your system, your BIOS hands off control to the operating system, the first partition that's consulted is the boot partition. Whether it's in the larger root or a separate partition, it's always consulted. Grub is launched, and grub launches the drivers necessary to interact with ext3 and read the remainder of the partitions and set up your system. So it's always ideal to define your boot partition as roughly 100 megabytes and also first, somewhere in the first area of your disk, so that your BIOS is able to get to it easily. Nowadays, however, modern computers have no trouble getting to the boot partition, regardless of its location on your hard drive, and also regardless of the size of your hard drive. To indicate the partition to be boot, just indicate /boot. Then select the type of file system, and which drives may participate, as well as the size. We're now down to the size field. We'll indicate that it should be 100 megabytes. It's a fixed size, so it'll be 100 megabytes by default. However, you can fill the maximum size of whatever you indicate, or you can fill all available space. So if it's the last partition that you're creating and you're not sure exactly how many megabytes or gigabytes are free or kilobytes, you can indicate fill all available space, and the remaining partition space will be consumed. You can also force the partition to be a primary partition, such as a bootable partition. And if for some reason you have difficulty booting the system without it being a primary partition, that's something you may want to look at. Generally, it works without it. So now we've got SDA1 being the boot partition. We want to create now another partition. Let's move forward and create home. Home is another important partition as it houses all of the home directories of the users on your system minus the root user, as the root user's home directory by default is placed beneath the root file system in a subdirectory named root. So we'll define this mount point as /home. Again, its type is ext3 by default, but if you scroll up, you'll see the other options are ext2, physical volume, software RAID, swap, and VFAT. VFAT is a type supported by USB devices such as pen devices and by various Windows operating systems. Again, later on we'll look at creating physical volumes using LVM, or we're setting up logical volume management during installation, as well as software RAID. For software RAID, we need enough, for both technologies in fact, we need enough hard drives to make it worthwhile. Although you could create a software RAID partition based on just one physical hard drive, although it isn't suggested for performance reasons. So, ext3 is the partition type of the day. It is the journaling file system, the extension of ext2. The home partition should be sizable, so let's make this 2,000 megabytes. The number is actually a little bit bigger. We could make it, instead of 1024 for 1 gigabyte, 2048 for 2 gigabytes. It's a fixed size, and it doesn't need to be a primary partition, and we don't need to fill the available space. So now we've got home, and we're down to about 6 gigabytes. Next partition. Another important partition is var. We'll also make it 2 gigabytes. /var. Any variable data, such as log information for your Apache web server, the kernel, Samba, VSFTPD, or any daemon you can think of, references the var mount point. So it makes sense to provide as much space as possible, but since we're operating within tight confines of only 8 gigabytes, we'll give it 2/8 or 2 gigabytes. It'll also be ext3, and we'll make it 2048 megabytes, and we missed that by tabbing over, so we'll just tab back and indicate 2048 megabytes or 2 gigabytes, and it's of a fixed size. Again, you have the option to fill a maximum size or fill all available space. So in other words, you can set a maximum size, let's say of 4 gigabytes, but the partition only occupy what it needs at any given time. In other words, like a variable sized mount point. So now we've got in total boot, var, and home. We need a swap partition, and optionally we can create other partitions, but we'll leave free space. It's always a good idea to have some free space in the event that we want to define, while the operating system's up and running, a new mount point. So we need a swap partition. That's new, and notice that each partition is incremented by 1 with a prefix of the hard drive, which is beneath the dev tree. So dev SDA provides access to the first SCSI hard drive or SATA hard drive. SDA1 represents the first partition, SDA2 the second, and SDA3 the third. So enter for new. And now when you create a swap partition, you don't actually indicate a mount point of /swap, for example, or /swap. This is unnecessary. Simply tab to the file system type and navigate to the swap type. When you navigate to swap type, notice above in the mount point area it says not applicable, because swap partitions aren't mounted to a mount point that's accessible in the user space. So as a consequence, you don't need to indicate a mount point. We do need to indicate, however, a size. Now usually you make your swap file or swap partition double existing random access memory. This virtual container or virtual server was configured with 256 megs of memory, but being that it's VMware, it can be tweaked on the fly, analogous to popping the box open and swapping out memory chips or adding memory chips. So you need to size it properly. 512 is an ideal size. Even if we were to double the random access memory that VMware provides to this instance, 512 would still suffice for our intents and purposes. And again, we can skip these options. It doesn't need to be a primary partition, but it will be of type swap. So now we have a swap partition that's in extended space. Now just a little note about partitioning on PCs. This isn't a limitation you'll find in the Unix or other worlds. Within a PC environment, there can only be 4 primary partitions, or optionally 3 primary partitions and 1 extended partition which houses a variable number of logical partitions. So what you see here with SDA4 is the operating system making use of extended partition technology. With extended partition, whatever space remains after the last primary partition up to the end of the hard drive is made use of. So in this case, SDA4 occupies the block after the last block occupied by SDA3. SDA3 begins at block 275 and terminates at 535, and it is a 2 gigabyte partition. SDA4, which is the extended container, begins at 536 and runs all the way to the end of the hard drive. It's just a container which allows us to reference a variable number of logical drives. But SDA4 has to be noted. It has to be recorded within the hard drive's partition table, which is why the swap partition was assigned SDA5. SDA5 is the first logical partition, and it begins at block 536, where the extended partition begins, and runs all the way up to block 600, occupying 509 megabytes. The calculation that's performed to determine the required number of blocks is based on the number of cylinders per heads on the hard drive, and it varies depending on the hard drive that's in use. The operating system performs those calculations for you. We simply indicate using layman terms such as kilobytes, megabytes, gigabytes, how much space we'd like to have allocated. If you want to create additional partitions, you'd simply navigate to New and continue to do so, but note that they'll be created as logical partitions, which means they're within the extended partition space, which is not a big deal. They're still referenceable. But just note that your swap space is not SDA4, it's SDA5. With that said, we have a custom partition layout, and if you have other partitions in mind, such as opt for optional programs, or even etc, or serve to store your web server files and FTP files, by all means use the space to create them, or create them while the system's up and running. But this will suffice to set up our system. With that said, let's tab over to OK. Again, you see the option for RAID in the event that you wanted to RAID your hard drive spaces, or your hard drives and partitions on hard drives. And also, do note that below there are function keys, or ways of accessing the same options that we can with tab using the function keys. We'll enter OK, and here it says we're missing our root partition, which makes perfect sense. In this case, you must have a root partition to install on. Notice there is no root partition, so we do need to define our root partition. We've created boot, var, home, and swap, but no root partition. So let's create the mount point as ext3, and we'll make root 2 gigabytes as well. And now we have a root partition. Now notice that the installer, Disk Druid in this case, the partitioning software used within the Red Hat installer, has elected to shift the partitions around. Immediately after boot, it's created root. And that's just to avoid any problems with grub locating the root file system, as the root file system is the important file system after the boot file system. The boot file system, or the boot mount point, contains the kernel. The root file system contains everything else, all of the other mount points. So as a result, the Disk Druid software knows to organize the root file system as one of the primary partitions on the hard drive, shifting things around a little bit, moving home into the extended space. So home is now SDA5, swap is SDA6. That works for us. Ultimately, we have just about 1.5 gigabytes free. Let's enter to see if Disk Druid is happy, and it is. It asks us if we'd like to use a bootloader, and the default is to use grub. Again, this depends on whether or not your system will be used in a dual boot capacity. So we'll use the grub bootloader, that is. If you need to pass in special options to the kernel in order to start your operating system, this is your opportunity to indicate those options. But once the system's up and running, you can also modify the grub startup environment beneath boot grub.conf, as well as the menu.list file, to determine how your kernel starts. Some systems need certain options, like the disabling or enabling of specific options, in order for Linux to start. But those are few and far between nowadays, as most systems work seamlessly with the default settings. We'll enter the OK. If you'd like to protect your grub startup environment, in other words, you will force users to enter a password in order to modify the grub settings, and here's an opportunity to do so. Spacebar on it and set a password. We'll set a simple password of ABC123, and now the grub startup environment will be protected, meaning users will be unable to interact with your grub startup environment, consequently changing the parameters passed to your kernel and the way your system starts up. In other words, if a user physically hacks your grub startup, they'll have access to your system. They can influence the system and consequently access your data and compromise your environment. Enter the OK. It says the boot manager users can boot other operating systems. You need to tell me what partitions you'd like to be able to boot. There's nothing else. The only thing that needs to be booted is the Red Hat Enterprise Linux server, and it's set as the default. So we'll enter OK. Would you like to install the bootloader in the master boot record of the hard drive, SDA, not of the first partition, but of the hard drive itself. Each hard drive, each PC-based hard drive, has a boot partition, or a master boot record, that is, which functions as the boot partition. It's 512 bytes, and grub writes enough information there so that when the BIOS launches that hard disk or hands over control to that hard disk, the first program that launches is the stage 1 grub 512 byte loader, which then calls stage 1.5 and sets up the menu that we see, which allows us to boot the remainder of the operating system. So the master boot record is where we'd like to place it. Now we also want to configure our Ethernet interface, so let's move forward. We'll activate on boot IPv4 and 6 support. Dynamic IP address information is fine for our intents and purpose. Automatic neighbor discovery is fine for IPv6. And let's configure the host name the old-fashioned way. This will be called Linux CBT serve 4.internal. The clock does not use UTC, however we are in the American New York time zone and we need a root password. And now we're ready to retrieve additional information regarding packages, so on and so forth. Depending on the classes of packages you'd like to have installed, such as web server, software development, you'll elect them or select them here. We'll just skip them. We're not interested in those options at this particular moment. We just want to have the system up and running with the custom partition layout so that we can move on and at least confirm that the custom partition space is in place. Dependencies need to be resolved. This takes a little while usually, so we'll wait this out and then return when it's completed. As you can see, we're at the halfway point. And again, this network installation is taking place within a VMware context. Makes it much easier for us to demonstrate the installation from soup to nuts, as opposed to pausing when the system reboots and capturing the screens and so on and so forth. But nonetheless, we've alternated between both the physical Dell box and the VMware emulated computers. In both cases, the installation processes have performed identically. Albeit within VMware it's emulated, but nonetheless, the concept remains the same. It still works likewise. And we'll just have one more check here before we move forward. And again, this installation process will yield an anaconda-ks.cfg file. For a Kickstart-based installation, simply rename the anaconda-ks.cfg to ks.cfg and publish that file in a place that's accessible. So we'll go ahead and enter here to move forward. And this will take us to the next step. So again, that kickstart file can be made available on a networked server such as an Apache web server. The file systems are being formatted. They're roughly 2 gigabytes each minus the swap partition, which is 512, and the boot partition, which is 100. And we will be looking at the Kickstart installation in addition to creating RAID and logical volumes during installation momentarily. This section is more to focus on, or this section's intent is to focus on a network-based installation within VMware with custom partitions. So we kind of lump those three technologies into one section. Then we focus again on network-based installation with RAID 5, and the network-based installation with logical volume management. And then we also focus on the Kickstart-based installation, all of which are required for certification. So now at this point, it'll take whatever the ETA returned to copy all of the files, although we elected not to install software development and the web server related files, so that'll reduce the number of programs that are copied, but nonetheless it'll still take some time, and we'll just kind of elapse the time and check in once the system's finish. And because we've elected to install in text mode and avoid X altogether, the system will start in run level number 3, which is fully multi-user, just no graphical environment, which isn't required, of course, for a server class system. And this is just checking out the installation source. Again, this is all occurring across the wire. And this tells us that it gave an error, and it's related to the size of the root file system. And that's because it needs a little more space to store the information. Now, rather than allowing us to fix things midstream, it forces us to reboot and go through the process, which is not a big deal. We'll quickly get to that point and do it again. So the root file system should be a little bigger, perhaps about 3 gigabytes, or maybe we'll make it 4 gigabytes. So Linux, ask method, and we want it to be in text. And we were hoping that we could fit the installation minus software development and web server within the 2 gigabyte space, but it was a little too small. But again, that's one of the flaws of the installation process, and one of the reasons why we prefer SUSE Linux, where at this point we'd be able to in SUSE simply back out or back up to the step where we indicate the size of the partitions, make the changes, and then move forward in the installation. So it's these little things, but nonetheless, it doesn't take too much time to run through the steps one more time. So it's going to be HTTP. We want everything to be dynamically assigned. This will download an IP from the server and configure IPv6 from the router. And the IP address of the web server is that. The path is RH5 I386, so that we can set up other architecture directories and use the single web server as a repository for multiple architectures. Again, Intel 64, AMD 64, and other supported environments such as IBM Z, S390, etc. We'll move forward. We'll skip the installation number. This will find the installation unless it's formatted the file system, and it doesn't find it, which is fine. So we'll create a custom layout because we got to the stage where it formatted it. So it has the layout, and the root file system will need to be reorganized. In fact, you can see that these file systems are there with no mount points. Probably the easiest thing to do is to delete the ones that you want to reorganize. So beginning with SDA2. SDA1 looks fine for the boot partition. And we'll delete SDA4. Now we got free space. So with that said, let's modify, this we haven't done, we'll hover over SDA1 and edit it, indicating the mount point to be boot. So this will be boot, And then we need a bigger root partition. We'll make it instead 4 gigabytes. And that'll be 4096. That should give us enough space for installation, leaving us about 4 gigabytes free. We want a var partition. Leaving us about 2 gigabytes. We'll make home 1 gigabyte. And that leaves us just enough space for swap at 512, with 512 left over. Again, just navigate to swap and that takes care of everything for you. Indicate the size and you should be fine. So now we've got the partitions that we'd like. Let's move forward. So we've got boot var home, swap, and it's a custom layout. We'll assign a password so that we can show you how this works once the system's rebooted. That's a default boot operating system and it'll be installed in the master boot record. And we want to configure networking so that we can communicate with the remainder of the network. IPv4 and 6 should be taken care of automatically. However, the host's name should be indicated manually. The clock does not use UTC, but we could change that. And root's password will be indicated. And now we move forward in the installation. We will skip the 2 package selections for web server and software development. We could, however, customize the software selection, which would allow us to pick the packages. Again, another area where we see that SUSE Linux excels over Red Hat in that even the software selection process is much cleaner, much more defined. It's well defined, whereas the Red Hat software environment leaves a lot to be desired, but nonetheless, it's usable. Let's move forward. And now the file systems will be formatted again. And we should have enough storage at this point with a 4 gigabyte root file system. So for your installation, ensure that you have at least roughly 3 gigabytes for the root file system if you're doing a custom partition layout. If you're taking the standard default layout, then have about 5 gigabytes free for full installation of Red Hat Enterprise. 5 gigabytes should cover what's necessary for the software. But of course, the more the merrier. If you can dedicate 10, 20, 50, and chop it up into different partitions, then it'll serve you well over the long run. So this will take a little while to run. We'll elapse it. Now we've got about 6 minutes left before the full installation is effected. And just under 1:40 left. And we're about wrapping up the installation. So, we're at a stage where we'll be able to reboot and see the installation to completion and confirm the layout of the custom partitions. So this is run pretty quickly. It's taken roughly 10 minutes to get all 2-point-something gigabytes of the OS installed. So it's exceeded our expectations in terms of installation time. Now let's reboot. We need to enter the VMware interface, the BIOS interface, so that it doesn't boot from the CD-ROM. Using minus, we'll push it down and push the hard drive up. And this will boot us directly to the Red Hat Enterprise Start menu, the grub menu. If you press any key you'll see the full grub menu. There it is. Now we can boot. You can edit it if you try to, for example. Because we've assigned a grub password, it'll prompt us to enter a password. Notice below it says press P to enter a password, and if we enter an incorrect password, it fails, giving us no access. Trying again with the correct password allows us to edit the interface, for example, launching into single user mode. So we can edit this and just type single and then boot from single, and now instead of booting into the typical startup environment, we'll be in single user mode momentarily, which will still give us the opportunity to confirm the environment. HD00 is consulted. That's the first hard drive, or SDA, (1), the first partition. It's ext2fs, and some detection of the system, including CPU, memory, and so on, takes place. The cache type for the SDA drive has been detected. Again, this is all emulated, but the underlying hardware is SATA based. And now we're up in single user mode. It doesn't even know the run level. However, a df-h shows the partitions that we've created during installation. We've got SDA1, the boot partition, which is 100 megabytes, 83 free. SDA2, which is the root partition, 4 gigabytes. About 2 gigabytes are available. SDA3 is var. SDA4 is the container for the extended partition, and SDA5 is the home partition. Swap on will display that SDA6 is a swap partition. So now we're up with a custom partition layout, and as promised, beneath root's home directory is the anaconda ks.cfg file. This file can be used to reinstall the system using Kickstart, which means hands-free installation. So we're done. This system is set up, and we can move on to other installation types. Let's reboot it one more time and alter the BIOS so that it starts up by booting with the CD-ROM. And again, that was an HTTP-based installation of Red Hat Enterprise Linux using custom partitions.